All right, guys. Let's. I just want to welcome you again in this program from the IAC Rise, and we are into the program where the motto is to cover as much as all the concept that can be solved with the language called Python, or I can say with the programming language called Python. Okay. So guys, today's topic is very important. Normally in the Python world, this topic come under the umbrella of some core concepts, or I can say some kind of advanced concept, right? So almost in all the major complex program or complex requirement, or I can say use cases, this is a very common situation, or this is a very common process or concept we have to use. So the today's agenda, guys, before we start discussing, guys, so today we are going to discuss about what exactly the mean of multi-threading and how we can implement the multi-threading, and plus again, with the way I started, we have to first discuss what exactly the mean of thread, or I can say single thread. Then we will move to multi-thread, and then we understand what all the kind of use case and concepts can be implement this part of multi-threading, right? So let's start from very zero. And if you guys was with me in my yesterday class, I have given you one homework or one task where I have written two different functions. Okay, and both the functions is doing something for you, and by chance both the function has some kind of infinite loop, and my requirement is to run both the function in parallel. So both will process by your CPU in the parallel. Okay, so guys, if you try to solve that use case, so one of the way to solve that particular task is with the help of a concept called multi-threading. So today's class, guy, I'm going to show you how the task I have given to you yesterday can be solved with this concept. Okay, but let me start this concept, guys, from very basics. So before you understand multi-threading, you have to understood what exact mean of the thread with respect to programming context, right? So let me start from here. What exactly the meaning of threading? So so guys, for this what I'm going to do, and by chance, guys, today the topic is on not only multi-threading, lots of some extra concept related to your operating system also you are going to learn. And there would be some kind of myth in operating system concepts. So first let me cover those myth to give you the right knowledge with some kind of great demonstration. And then that concept will slowly lead us to understand what exactly meaning of the thread, and then we move to the multi-threading. Okay, and then what kind of use case they solve for us. So for today's demonstration, I'm again going to use for some small reason, I'm going to use Red Hat Linux operating system. You can do the same practical on Windows also, but Linux will give you extra knowledge to visualize the right concepts of the thread. Okay, so let me start from here. Okay, so guys, one small thing that we have discussed already in my initial class is if you want to do something on the top of operating system, and technically the meaning of the operating system is it is the one who operate your system. And when I say system, I normally mean to say physical devices. It may be RAM, it may be CPU, your network card, your speaker, wireless card, mic, and some more things, or maybe graphics card. But if you want, as a human being or as a user, if you want your operating system will operate something, so you have to talk to the operating system, or I can say you have to give some signal, or I can use one word here, you have to give some instruction to your operating system. And the way you can give the instruction to the operating system is by with the help of interpreter or maybe with the help of compilers. Okay, one of the interpreter we have, guys, we have is Python. So as a user, we can talk to the Python, say, Python, can you please help me, and can you take one information from my behalf to the operating system and ask the operating system will do something for us. Maybe they contact to mic, they contact to network devices, or they contact to somewhere else. So this part, guys, you know. But here the key term is instruction that I'm going to very soon relate to the word called thread. Okay, now one more thing, guys, you know. Okay, for this, if you want to give the instruction to the operating system with the help of some language or interpreter called Python, you have to write a code. And in the code, the code that you code normally you have to write in a file. This file is called a program file, you guys know. Okay, but if you write the code, you have to write the code in a file, and file normally store in your storage or hard disk in the storage. Okay, you guys know this point we discussed multiple times. But whenever you double click the file or execute the file, this entire file will from your hard disk or from the storage load on the top of your RAM, or I can say the memory. Okay, now from here, guys, here you guys know. But from here we will move to our today's main topic. Okay, but you guys know one more thing. Till the time your code is reside or store inside your hard disk, or I can say the storage, that is known as program. This code is known as program. But as soon as you execute an entire code, when they load on the top of the RAM, okay, that code or that all the code become a process. Or there is somebody in the OS, in all the OS, they are the one they are the one who give every process some unique number, and that unique number is called PID and process ID. So in the operating system, there is one core internal program and known as kernel. So kernel is the one, it is there in all the operating system, is the one who gave every process some unique ID called process ID. Okay, maybe Windows or maybe Linux. Okay, this is one thing. But one more thing, guys, if I try to relate from my yesterday topic, so whenever, guys, you create a code in one program file, especially in the Python, and after you execute the code, the entire code is stored in one box, and then only you can run the code or run every line of the code. And you guys know every line of the code is known as statement. So either, guys, I can use the word statement here, or I can use the word called instruction here. So maybe in the code you have 10 different statements, or I can say 10 different instructions you have. Okay, but if you want to run any of the statement, right, you have to put the statement in this box. And who will put this in this box? So for my yesterday class, guy, I explained you in the Python behind the scene, they create one box inside the RAM. Okay, or on the top of the RAM. And this box, guy, I told you the name yesterday called namespace. The namespace the Python create behind the scene is called __ main, or I can say __ main, or main namespace. So this might not be so important, but I just want to revise what exactly we discussed yesterday. But the important thing here is the process. Okay, it means if you want to do something, okay, and if you want your OS will do something for you, the only way is to start the process from the program. Otherwise, OS won't do for you. Till here, guys, everybody know this concept, right? Because we had discussed multiple times, right? But the most important point is what is there in the process. So in the process, guys, maybe you have write code, and this code has a first statement, maybe print or for loop or while loop or variables and XYZ you write. Let's say you have 4 or 5 different statement or instructions you have. Okay, so now interesting point over here to notice, there's 2 or 3 important point to be noticed here. Let me start from this point, then I'll slowly move to actual concept for today called instruction, that slowly I will relate to the thread. Okay, so first of all, guys, whenever you execute any program, it becomes process, and process has been assigned a one PID is called process ID. Okay, so very quickly let me show you what exactly I want like to present you here. Then I move to main topic. But but guys, one more interesting concept here is, right, if I ask you if I ask you what is the right meaning of the PID, what exactly the process ID is, okay? Or if I say, if I say in this way, whenever you execute the program, it start a process on the top of the RAM. So it means somewhere on the RAM, somewhere on the top of the RAM or memory, this process, let's say this is a Firefox. So Firefox is a program, I double click, execute, it become process. I can say Firefox process started, and your kernel or your operating system internally give Firefox some unique PID or PID, let's say 1234. And this 1234 is somewhere also located on the top of the RAM. So my question, guys, for everyone over here is what do you think, guys? What exactly this process ID, if you talk with respect to the RAM? So this is just a number, or maybe your operating system create one folder for this, or maybe this is one kind of file they create, or maybe nothing, or maybe some kind of one table they create and say Firefox is a process having this ID, VLC is a process having this ID, and something like this. So technically, if you try to think, just you think in this way, let's say you open the RAM or memory, okay, and you might see some number there as a process ID 1234. What do you think? What is number would be technically, right? It's just a number written in some table, or maybe it is a folder, it is a file. What you think it is? Okay, but guys, normally we don't think in this way. We don't think much about the process ID. But if you know, if somebody, if you ask this question to somebody, can you please tell me what is process ID? 99.99% I can say, I can give the guarantee. They say it's just a number. Maybe on the RAM, somebody has created some table where all the process that is running in this operating system, they maintain some IDs on inside this table or in this index maybe. But technically, guys, this actual answer you'll get, I can give you the guarantee, right? But this is a pure wrong information, or I can say the myth. Okay, the right concept that I'm going to show you right now with the real practical, I will visualize you. That is, if you talk about the process ID in any of the operating system that we assign to the process, it is you know what it is, right? It is actually a folder or a directory. What I mean by this, whenever you execute any program, let's say Firefox, even though let me show you here also. So whenever you execute any program, okay, for example, in my case, this is a Linux operating system, and in the Linux operating system, if you want to see the total number of process running right now, so there's one command called ps space -aux. This will show you all the process right now running in my operating system. Or for example, if you want to see in the Windows, you can open a task manager. Task manager will show you. But this is a command in the Linux. So these are all the processes running in my system right now. Maybe when I started this OS, behind the scene, they started all these processes. For example, one of the process name they are running here. Let me run this command again. Is maybe evolution or GSD printer or something like this. But if you want to search, do we have any Firefox process running? Obviously not, because we haven't started Firefox. Or rather than you just go up and search, you can use one command called pipe in the Linux, is a key in the keyboard, and search grep is a command, and say, do we have any Firefox process running? So it's not, there's no Firefox process running. Or maybe do you have any Python program running? You can see search by this command. Okay, but as soon as you click on this program here in the top, so this is a program. But as soon as you click, this program from the hard disk load at the top of memory on RAM, and as soon as they load, the Firefox process start. Or as soon as the Firefox process start, right, my system or system internal kernel has give some unique ID to this process. So again, if I run this, now you can see there's something difference come up, and this is the first line. First line you will see here. Okay, this is the name of the Firefox process, and this is the ID by chance in this case 3113 given to this process. So now again, my guys, question to you, what do you think, what 3113 here? We know this is process ID, but if you go inside the RAM okay, what you will see, it is not just an ID. Behind the scene, your operating system has created one folder for you. So it is something like this. Whenever you click on the Firefox process, right, your operating system will go up to your RAM and create one folder or one directory for you. And why they create? Because because Firefox is a program. A program is a code, or maybe this program will contain some documents, some images, some more information. So whenever you guys double click on the Firefox, or maybe VLC player, or maybe Python code, it will be any kind of program. The entire the code of the Firefox and the related data, they store inside this folder. Or where they create this folder they create inside your memory on the RAM. And why they put in this folder? Because folder, guys, is the simplest way to manage the thing. Because maybe Firefox might contain multiple different code or multiple different code, maybe in multiple different files or program file. So if they create the folder, it would be very simple to manage. And because they create the folder, so they try to give a folder unique name. So they give some name, or the name of the folder is exactly equals to the PID, process ID. So technically, whenever you launch any program, it becomes process, and every process they give the folder PID. But this PID is for us, it is just a process ID. But if you go inside the RAM, that I'll show you in a minute. We will, guys, today we'll go inside the RAM and I'll show you, okay, all the folder created in the RAM. Technically for the RAM, those will be the folder, but for the operating system perspective, these are the process ID. So I'm trying to tell you guys here is process ID is just not the ID. It is actually a folder, and this folder contain all the data. Maybe this might be Python code. So maybe in the Python code you have x equal to 5 as a variable or some other code. Entire data would be reside inside this folder, and this folder is there on the RAM. And how can I visualize? Okay, there's one way. Okay, so in the Linux operating system, maybe operating system to operating system, this might vary to see the RAM, but the logic would be same. But in the Linux operating system, guys, RAM is again one kind of you can say place or space where you can store something. So this RAM in the Linux system, guys, they link to one folder, and that folder is called /proc. And this link normally is known as mount. But technically it means if you want to see what is there in right now on the top of your RAM. Okay, obviously, guys, normally on the top of the RAM, we have a lot of process running. And every process we give unique ID. Even though if you see here, there are a lot of process running here. But every process, guys, system has given some unique IDs. But for us, it is just ID. But internally, if you go to RAM, every ID has their own personal folder. Or I can say for the RAM, it is a folder, but OS will present you not as a folder. They present you as a PID. Okay. So if you want to see all the folders or the PID in this operating system, then we can go to the RAM. And if you want to go to the RAM, this folder called /proc. So let me show you here. So if I go to /proc folder, /proc should contain. I think guys, there's some second of disruption in the internet connection over here. Okay, but right now I'm into my folder in my RAM, and if you run the ps command, so Firefox is a process, and this process has this folder. So this process has this PID, and for the RAM perspective, okay, what you will see on the RAM 3113 has one kind of folder created. Means if you go to this folder and you run ls, what you'll find here, there is one folder called 3113 here. And guys, this folder we haven't created. Who created? My OS created, or my OS kernel created. When I launch my Firefox. And this is a little folder, right? I can go inside this. Okay, but as soon as I close my Firefox, your process stops. And if the process stops, if you run now your ps command or task manager, maybe you'll see Firefox stops. Okay, but you know what, guys? What I mean by a process stops. So till date, guys, you everybody know how to close the Firefox or VLC player. Or I can say I would like to terminate my Firefox. You know what's the meaning of terminate? Terminate means technically my OS will go inside the RAM and delete the entire folder. And normally in our technical world, we normally say we have terminated this program or this process. Or sometimes we also say we kill this process. So normally we use this word called kill or terminate. But internally, as a OS perspective, what they have done, sorry, they go inside the RAM and they remove the folder. And how can I show this? Again, if I go to the same folder, I'm already here. If you ls, so last time I showed you guys, there's a folder called 3113 was there, but my OS has terminated or removed the entire folder. So what I'm trying to prove you guys here is, okay, PID is a PID, you can say, but technically and logically or practically, or I can say internally also, it is a folder created on inside the RAM. Let me show you one more time. So let me again start my Firefox as a process. Okay, so as soon as the Firefox start, system will give one unique PID, or I can say now, system has created one unique folder on the top of the RAM. And how can you find the name of that folder? With this command. So this time, guys, because every time they might give a unique or different or ID or random ID to you. So this time they created this pre-ID code 3560. It means if I go inside the RAM that I already in, you will see there's one folder they created. It's called 3560. Last time I don't have this folder 3560, even though if you see here, there's no 3560 folder available. But now if I do ls, you will see this folder created. And because this is a folder, so I can go inside this folder. I can go inside this folder. So, you know, the interesting thing is this might be the first time, so guys, this might be first time you are going, because, you know, till the time you think PID is just a name or number, nobody can think we can go inside the PID. But now we know exactly the meaning of PID. PID is actually folder, or because PID is folder, we know the concept, so we can think to go inside this folder. Or I can say this is my first time you are going inside the PID, and that's what we have done. But what this PID is folder, and what does this PID folder contain? All the content of the Firefox, not the program, process. So this might be first time, guys. Might be first time we are going inside the process. Till date, guys, we are using the process. For example, this is a Chrome, right? This is a process we are using right now. Okay, so everybody know how to use the process, but here I'm talking about how to go inside the process. Okay, so 1 minute. So we are inside the process, and if you want to see what exactly there inside the process, you can do ls. And this is very interesting, guys. If you really want to understand the concept of the operating system, maybe somebody are doing some kind of technical graduation, maybe BTech or BCA or MCA or some master degree, or maybe somebody already graduated, right? So maybe while doing the graduation in the college and the universities, we have one topic called operating system, is one subject we have. And inside the operating system, there's one subject called entire topic called process management. And that time you normally learn the process management very theoretically. But that time, guys, they talk a lot about a concept called limit. They talk about a concept called schedules, concept called numas, concept called system calls, and other things. Okay, so you know what I'm trying to tell you here is, right, if you are learning some concept theoretically, and same time you can visualize those concepts over here with the really you go to inside the OS and the RAM, and that time if you the theoretical concept you are learning, and if you are try to also visualize this concept practically, the learning would be more logical. More interest will generate. And the most important thing is, right, most important thing is we can verify whatever written in the book, what somebody is teaching to us, right, from these these files, because these are real files, these are real process data. From these files we can open, and actually we can verify whatever written in the Wikipedia or books or whatever somebody is teaching to us. We can confirm that somebody is talking something, let's say about threading, multi-threading, and I come to some of the file here to verify does this is the right or not. So my point here is my final conclusion here is, if you know the right concept, that PID is a folder, and because a folder I can go inside, and because I can go inside, and then I start learning a concept related to process, this makes more sense because I have now some tool, some platform to verify that information. Maybe you guys might have heard about ohms, or maybe heard about stack and other things. Maybe. Okay. So finally, guys, what I concluded here till now, PID is equal to folder. That's all. That's the one thing I concluded. Now come back to main topic called thread. Okay, why I explain this topic right now, PID, because in a 5 minute, while explaining your concept called thread, that's our main topic for today. Okay, this PID concept and this folder we are going to use to verify something. What is that? In a 5 minute you come to know. Okay, so let's start the topic called thread. Okay, but before guys I start this topic, very simple concept I just want to tell you, most of the guys might know. Okay, so again same thing, when you write a program file, inside the program file you write the code. In the code you have multiple statement. When you double click, entire code load on the top of RAM, it become process. But process related thing, or the folder or the data reside on the top of the RAM that I showed you here. Over here. Okay, but but guys, if you want to do something in the process, for example in the process you have 4 lines of code. You need somebody who run this code, who do something with this code, who run this statement for you. So you guys know who run this statement for you. CPU is the one who run your statement for you. Okay, so what happened guys, as soon as you double click on the program, process start, and in this process the entire process go to CPU, and CPU is the one who execute your process. But and this is one more interesting thing here is, right, maybe sorry, maybe your program contain a code, and very quickly if I write my code here, let's forget about the Firefox for a while. Okay, let me go for code. So I'm going to create one folder called T. And this folder I'm going to write one code, let's say t.py. Okay, and in this file guys I'm writing one statement here, let's say A. One more statement let me write here is B. So there's 2 function I have used. Print is one function you guys know. Okay, and let me use C. So in this file we have 3 statements, okay, or 3 function. But I told you in my last class is every statement may be x equal to 5. But internally in the interpreter perspective, equality is also one kind of function. It means whatever you write in this file is a function. But let's say these are the instructions or the statement. Okay, so these are the 3 statements we have. Let me save and let me run this. You guys know how to run Python, Python 3, and let me run this. Output come up. Pretty straightforward, nothing very fancy, but interesting thing is, if I try to draw here, okay, so what happened whenever you execute your program, so execute this program, the entire code instruction load on the top of the RAM, and till the time guys this program until the time this program is executing, a process is running. Where? On the top of the RAM. Until the time process running, your system kernel has given, or system OS has given some unique PID. But till the time your process is running, because this code has very small lines of code, or 3 lines of code, so very quickly they close, very quickly they stop that process, they stop the PID, or they remove the PID. But what I'm doing here, just for a small testing, what I'm doing here, I just want to keep on running this program for a long time. And one of the simplest way, I can use input function. Because input is a one function or a statement. The beautiful thing about the input function is, right, till the time, okay, this is my entire code, So I am again executing this process. Now, the interesting thing is, input function is when you guys know till the time I hit enter, it keep on running, or till the time input function is keep on running. Okay, your program or process keep on running. And till the time guys process keep on running, now this point in time, because my process keep on running, so if I go again and search any process related to Python 3, Python 3, so you can see guys this process running. Or because this process is running, I can see the process ID. Or because I know the process ID, so I can go inside this process inside the RAM. And if you root ls, okay, these are all the data related to this folder or this process or related to this program. Or this might be the first time, okay, maybe guys till date, we always execute the program and see the output. Okay, or we always see the running process. But this might be first time guys you are going inside the process inside the RAM. And why so useful? In 5.0 we are going to use some of the data from here. Okay, this is one small thing. So guys, so one thing, and second thing guys, I just want to tell you here is one minute guys please. Okay, so second thing I would like to tell you here is that I explain you, as soon as you execute this program, a process is running on the RAM, and what this process contain, this 4 statement, or I can use one more vocabulary here, 4 instruction. And who printed A and B and C, or who stopped me here, because input function is saying please enter here. So who paused this program, or not pause, who stops me here. Okay, this instruction, but technically this instruction is run by CPU. So CPU is the one who run this statement, and CPU is the one who run this statement, or this is an instruction. But you know what I'm trying to finally tell you here is, right, who give the instruction to CPU? Process. But technically guys, whenever you run the process has one limitation. Process has one limitation. Okay, so guys, if you use any operating system or any programming language, maybe C, Java, Python, every process by default has one limitation. And limitation is in the process is, right, in the process, if you have 4 statement, 2 statement, or maybe 100 statement guys, behind the scene they send one instruction at a time to the CPU. They never send all the statement to the CPU. Or they never send all the instruction to the CPU at the same time. Okay, so technically it work like this guys. This is very important point to be noticed here, is because it's highly related to our main topic called thread. So technically, when I execute this program, process start, and behind the scene process pick first statement or first instruction. Okay, or after the pick first statement or first instruction, they send this instruction to the CPU and say, can you please help me to run or execute these and give me the output. And maybe this time, maybe here, CPU might take, let's say, 1 second to run this. Maybe CPU might take 1 second to run second one. Might take maybe this point 2 seconds to run this. But the most important thing here is, if let's say third statement consume 2 seconds to run by the CPU. So till the time it fully completed, fully executed, okay, your process, not CPU, your process won't send next statement to the CPU. Because nowadays guys, we have multiple CPUs run with us. Okay, and CPU is the one who doing everything for us. So let's say CPU 1, CPU 2, 2 CPU we have. We have here. Okay, but let's say CPU 1 is busy in running your third statement on the instruction. But CPU to say, I am free, I know there's no task to me. Can you please help me to give some other task? Or maybe some other task is waiting for us. Let's say input function. But this process say, but the process say, I can't give you my next, next statement or next instruction till the time the older one finished or completed. So guys, this is one of the limitation or by default, by design limitation in any of the process, in any of the language, in any of the operating system in the world. This is the way it works. Okay, and I just want to give you one more vocabulary here, right? For this, for the CPU perspective, for the CPU perspective, if any process, if any process give CPU some task, I told you guys they never give you entire code. They only give one instruction, one statement at a time. Okay, but for the CPU's perspective, whenever any process come to the CPU and say, hey, print A is one statement I'm giving to you, or I can say one function I'm giving to you. So, according to CPU, they treat this statement or the instruction or function, they treat this guy that is called thread. They say one thread coming. Or because process has a limitation, they can send only one statement or one instruction at a time. So I can say process can send only one single thread at a time. Or because process can send or can take the help from the CPU to run only one thread at a time. So I can say all the process, whatever we guys run till date, is a single threaded process. Okay, so I can say the process that I have written here, I have right here or running here is single threaded. Okay, and right now because my input is a statement or the function run by my CPU, until the time guys input function completed, it won't go to next statement. Okay, maybe I might have more statement, but they won't go to next statement. So I can say this program has started this process, and this process is single threaded. Okay, because this is a single threaded, and this is not the limitation of the CPU. CPU might be maybe free this time. They say I can run more statement, but this is the limitation of my program, or I can say my process. And how I confirm this? Okay, how you can confirm that your process is running a single thread? And here by chance the single thread name is this statement, because we stuck here, or we are waiting for this to be complete by the CPU. And CPU is not complete because input function need enter to complete. There's a different point. So how can I confirm this process, or I can say this process is a single threaded? So best way to confirm is go inside this process, and we know this process folder. So go inside the folder and ask this process directly, right? Why we have to ask to the CPU? Ask this process directly. Can you please tell me how many thread you are running right now? And how to ask? Every process has their own personal status file. So if I open this file, you can use gedit or other way also. Just as it is a normal text file. So if you open this file, what this file will tell you? Okay, this file will tell you about this process in detail. They give you all the information about this process. One of the information they tell you about the process is this process is Python 3 process. The ID of this process. That we already know. But if you go down, they will tell you lots of things about the processes. Maybe in some advanced discussion somewhere you guys might go through this information. But if you go down, and you can see some extra thing about this process. And one of the things that I'm interested here is called threads. So by default, guys, if you see here, in this process, one single thread is running. It means this process have a capability right now to run one single thread at a time. Or I can say this process has a capability to send one single thread to the CPU. Or this process has a capability to send one single statement, or a statement, or I can say use the one word called function here. So instruction, statement, or maybe function or thread, it is a similar kind of things used in different angles, but you can think maybe some might difference, but it's a very similar kind of thing. Okay, to be discussed here. So finally, what I'm trying to explain, guys, here is 1 minute. So what I'm trying to explain here is, all right, that what is the thread. Okay, so whenever you execute a program and it become a process has a limitation to run only one statement or one single thread at a time. And that is the reason, guys. Now if you guys link to my yesterday task or yesterday homework, now you can very easily link why we are seeing that particular challenge. Okay, what I mean by this, if I create a program again, what we had created yesterday. So guys, yesterday we had created this program. Okay, what we did, let me remove this code, and we had created one function, let's say a, and in this function we had created one while loop, is an infinite loop, and here I just printed a multiple times. The same way I created one more function yesterday called b, and again it is a infinite function, and this function, when somebody call this function, they run bbb here. And what I wanted to run the a function, and I wanted to run the b function. And guys, I explained you yesterday, and now I think you can link this explanation very clearly today. So what I explained you yesterday, whenever you execute this program, they start a process. And duty of process is to do one thing. Okay, the one thing is okay, they will go inside your code and see which part we have to execute and we have to send to the CPU to work on, or which statement we have to send to the CPU, or which thread we have to send to the CPU. So they go here and say, this process say, this is just a definition. We don't have to run this line, this line, this line. We have to just memorize this line on the memory. Because I told you my yesterday class or my last class also, when you define, internally they create one variable, and inside this variable, they put all the data. Okay, so think like it is not we don't have to execute this. We have to just create a function or define the function. So this line, we don't have to execute with the help of CPU. We just have to memorize on the top of RAM. Plus, if you go to the next line, again, we don't have to execute. We have to just memorize that somebody has created this function. Maybe somebody will call in the future. That time we will execute. Till that, I have to just memorize on my top of my memory or my RAM. But whenever, guys, you reach to, let's say this is the first line, the second line, we don't have to run. But whenever you reach to this line, and I told you multiple times, the meaning of this parenthesis is, first of all, this a is a function, and second, we want to go to memory wherever we define the a, and we are calling this a, means we are asking to execute. But here, guys, if you see, is only one statement. So technically, for this point of line perspective, we are asking to execute one instruction. Or guys, because, and same way we have one more instruction to execute. So technically, after this instruction, we have to run this statement or this instruction. So let me give instruction number 1 and a statement or instruction number 2. But I told you guys the limitation of process. Process can only execute one statement at a time. Okay, so my process will send a instruction to the CPU and ask CPU to run it. And the challenge is, guys, CPU, when you send something to CPU will complete this statement till the time statement complete. And challenge, guys, here, this statement is a function, and function, guys, if you go to this function, this is not the normal function, it is infinite loop. So this function never complete. Because they never complete, CPU keep on running. Or till the time, guys, CPUs keep on running, right? CPU won't again send to the process and say, this statement, what you given to me is completed. Now it is time to send me the second statement. Or it's time to send me the second thread. And guys, that is the reason, right? This statement is keep on running. We we won't reach here, because this statement is infinity and CPU is keep on running. So let me guys run this code again one more time. We have shown you this code yesterday already, but let me save this file and let me execute. Look, I see here only A is printing, B will never print. And that is our target, guys. We have to create a code where A and B both will print. But till our current knowledge, or till our current knowledge of single threading, because this is single thread. And how I confirm? Very simple. I can just go and find the process ID of this guy. Okay, this time, guys, the process ID of this program is 4262. I'm there in the RAM, and I open the file called status. And what I find about this process only one single thread is running. So if you go up, one single thread running. Or because one thread running, it means only CPU running one thread at a time. CPU may be free, but we have a challenge in the process single threaded, so it won't run two thread in parallel. But first thread never complete, so second thread never get a chance to run. I just terminated this program with Control C. There's a different point, but second thread never get a chance, or second statement never get the chance. So what's the plan, guys? My task was, right? You have to create a program that A and B, first of all, they never complete. But I want to create a program that A and B both will run parallel. So I want to send both the statement or both the instruction or maybe more instruction to the CPU. How? In parallel. So you can see, you can think in this way. Okay, by default nature of the CPU, we send first statement CPU complete, we send second statement CPU complete, we send third statement CPU complete. So by default nature of the program is serial kind of thing, one by one. But if some statement consume a lot of time, and I don't want to wait for this guy, I would like to go to next and run other statement. So you have to go with the concept called parallel or parallelism. And if you want to achieve the parallel or parallelism, then we have to remove one limitation of the CPU is called single threaded. Because process has a not CPU, I say process has a issue of single threaded. That is only one statement will go to CPU at one point in time. But what can we do? Now we can tell the process, can you do one thing? You have one statement, second instruction, third statement or third instructions, right? Can you do one thing? Can you please send both the statement or all the three statement to the CPU at the same time? Can you do this? Or I can say at the CPU perspective, what CPU will see? CPU is seeing one of the process we have, they send three statement or two statement or 10 statement at the same time. Or you have maybe a lot of CPU, or CPU very quick in running the things by some kind of with the help of some queue or some other things we might discuss in the future classes. So where they're very quick, right, to run multiple things in parallel. So CPU say I can run it for you, but if your process has to send me. So it means for the CPU perspective, what CPU see, this process are sending multiple thread to me, multiple statement to me. And guys, that is called multi-threading. But for multi-threading, you have to enable this feature inside your process. And guys, if you want to enable some feature inside the process, then you have to write some extra code inside your program. Because from the program process starts. Okay, and guys, that's what our main topic for today. And because this topic, I given you a lot of background about CPU, proc file, other things also. So I can visualize you. Otherwise, multi-threading topic is a 10-minute topic, 1 or 2 lines of code. We have to write extra, but I just want to visualize that this actually happening behind the scene. It is not about the Python. It is about any other programming language also. Okay. So technically, the topic is multi-threading. It means one process can send multiple statement or multiple instruction or multiple thread to the CPU, and CPU is very quick, very fast. They will run all the statement for us, right? How? In parallel. Okay. But I can, if I little bit more elaborate, it look like parallel, because they are so fast, but technically it is not. What I mean by this, might not able to explain you today, but I will explain you in my future class. But till that time, just think it is a parallel. But that's what you can visualize here in some minutes. So let me start, guys, with the multi-threading. How I convert my program in multi-threading. And you know what, guys? This is actual. Concept used by almost all the programs in the market. For example, if you go to Firefox again, somebody has written this program and I executed this program, it becomes process. Okay, and guys, right now in the Firefox, you open this tab, you open the Google here, you open one more tab, you open Firefox here, you open one more tab here, and plus some lots of things Firefox is doing behind this thing for you. Maybe they are updating your Firefox, so you're downloading some libraries. Maybe some more thing you're doing behind it. They are showing the image, they are accessing some websites. So one single program, right, in parallel or simultaneously, I can say, doing lots of activity for you. Normally, in the simple terminology in the computer world, it is known as multitasking. So normally, normally, one program do multiple tasks for us. Task for normally this terminology we use a lot with the OS perspective. For example, this is my this is my operating system. And in this operating system, guys, I'm using Chrome, I'm using some other program and all the program, guys, working together. Normally this is called multitasking. So as an OS perspective, if you run multiple program, maybe Firefox or Chrome or VLC player, or maybe some other program, and work we can work with all the program together or in parallel. Normally that is called multitasking. Okay, so normally in the OS world perspective, this is the normal basic term we use. But but if you talk about a process perspective, okay, and here the example is called Firefox. If just one process, if they do multiple thing in parallel, we might use, or we can use the word called multitasking, but the better word I can use here, technological wise, is called multi-threading. There's one more word here, guys, it's called multiprocessing. So maybe in my upcoming class I will talk about multiprocessing. So it is a different concept altogether. But for this we have to need some more concept of the operating system we will discuss in my future classes. So this is not the topic for today. Okay, but if you have one program running, for example, Firefox is doing lots of things for you. For example, they might be using Google. Same time, I can also access Facebook. So one process are doing multiple things in parallel here. Both the things are working parallel. It means this one single process are sending all the requests here to CPU, and CPU is running all the requests in parallel. So it's but obvious, guys, this process is running multi-thread. And how can I assure? I can check, right? How I can check? I will run the ps command to check the PID of the Firefox. Okay, and if you go up, this is the PID of the Firefox 34399, and if I go inside this folder, inside my RAM, other way also we have to see this. And if you open the file of this particular process, and this is a process of Firefox, what I can see right now of this process, Firefox running 55 different threads this point in time. Or maybe some of the thread has done, maybe some of the thread might be just to show you this image, or show you this image, or show you this data. Maybe lots of things is happening behind this, it might not be visible to us. Some of the tasks doing by this process might have been done. So maybe after some second, if you again go inside this process, you might see some extra thread come up, or you might see some of other thread maybe down. So if you again go up, last time it was 55, or now see it becomes 56. Maybe some extra things behind the scene they started. So technically, guys, each but always 55, 50, 100 different threads are run by normal your programs and by the processes. Okay, and because they have thread, that is the reason, guys, we can do hundreds of things here. I can open more tabs, I can open more tabs, and now if I see here, if I again open this file, you might see some more new threads open, or some might close behind the scene. So if this thread is not there, so it will be very harder, or maybe might not be possible in one single process we can do multiple things, right? For example, this tab is open and I open new tab, but maybe my older tab is doing something. Till the time my older tab completes all the things, my new tab won't open, or might not work, or maybe hang up, or maybe other issues will come up. So because of multi-threading, because multi-threading is a facility of the process, this process can do lots of things in parallel. This is one of the example you can see. Or maybe if you go to VLC player, for example. So in the VLC player, guys, we can get a playlist. We are running the video, audio also coming. We have a pause button. Maybe something you're getting live streaming. So tons of different things is happening behind the scene. Okay, and I told you my yesterday class, guys, for play, we have a different function. For getting data from the internet, we might have to write different function. Video is coming on the screen, we might have different functions. So 3 functions running there. But all the functions have to run in parallel. Otherwise, you won't get the things what you wanted. Okay, so it means, again, they are running 3 threads maybe in the parallel. Again, that is called multi-threading. So without having the multi-threading, none of the real world kind of software and program can be created. And guys, that's what we are doing here. So how can we convert this single threaded program into the multi-threading? That's what, guys, we have to do. And guys, it's so simple to do. What we have to do, just in the Python, there is a function called threading that we have to import. That's all. Okay, so this module has given a capability to Python that to convert this program, or the process run by this program, into the multi-threading. Okay, now it is your choice. It is your choice how many thread you want to create. But understand one thing that is very clear, right? If in the process, if you want your process send 2 instruction to the CPU, or 3 instruction to the CPU, right, in parallel. So CPU will run all the thing in parallel. So you have to get 1, 2, and 3 threads. Okay, so maybe in your code you have thousands of lines of code, or maybe in your code you have 10 different functions, but you have to plan which all 2, 3, 10 different functions you send to the CPU in the same time, or in the parallel, or you want these will be run in the parallel. So my requirement is, guys, I would like to send this function and this function, both the function to the CPU at the same time. So CPU will run both the guy in the same time. So it means I want 2 threads to be complete or to be created. Okay, so how we can do? So for this, in the threading module, we have a function called thread. And in this thread function, guys, so this is the function who will create a thread for you. But here you have to be specify, right, which function you have to call, or you have to send it to the CPU as a thread, or as a parallel, or in parallel. So for this function, let's say I would like to send A to my CPU as extra thread. So this A function would be target for me. So guys, in the thread function, we have one argument called target, and here the target is A. Or maybe in the same time, I'll tell him my threading function, threading module, and the function name is thread. I think T is capital here in the function. And I say I would like to create one more thread, means I will send one more function to CPU at the same time. So again, I have one more target, and name of target is B function. And guys, understand one thing, right? Here A is a function, but I'm not writing this. Because when you write this, it means we are not getting the code from this guy, or we are not giving the reference of this function. Okay, this means I would like to execute here, but I don't want to execute here. Here I just want to give a reference of this function to thread and asking thread this in my memory somewhere you find a as a variable or a as a function, just go there, get the entire data and put the entire data in one box, and this box called thread. And guys, if you guys don't understand this point, don't worry. You guys might miss my function class. There I explain you function is actually a kind of variable or is a kind of a reference. Okay. So technically, if you want, you might have a lot of function either created by you or created by somebody else. But if you want this function and this function, both will go as an extra thread. And guys, now understand one more word here. What I mean by extra thread. Okay, what I mean by extra thread here. Whenever you and I'm just referring to my yesterday class also. Whenever you run any code, especially if you talk about Python here, I told you guys, whenever you execute Python, behind the scene Python create one I can say one statement for you or one box for you, and this box is the one who run your further function or statement. And this box is called main box or main namespace. So technically what I'm talking about, whenever you execute a Python code, in this Python code, you write any code, you don't write any code, you write function, you call function, you don't call function, you write variable or you don't write variables, right? Or you create thread or you don't create thread. Main module or main namespace, or I can say main function always run. Or they keep on running. And the life of there is the life of this program. So till the time the program run or till the time the process run, this main function is keep on running behind the scene. Or because main function is keep on running, it means a CPU is keep on running the main function. Means this main thread is always go to CPU and CPU will continue running this main function. That is a reason, guys, whatever you have in the main function, okay, is run. For example, let me explain this way. For example, when I run Python, main function start. And the main function, guys, is keep on running behind the scene to the CPU. So, or I can say one single thread is keep on running. And in this single thread, I'm sending this instruction, I'm sending this instruction, I'm sending this instruction. So all this instruction or statement is going inside my main first thread. But as soon as I close this program, my main thread stops. Or I can say my, because I have single thread, so my process or program also stops. So guys, technically, if you use any programming language, one single thread always run for you till the end of your process. And normally it is known as a main thread. And they always run. But in our example, I have created two more extra thread, this one and this one. And the responsibility of this thread is to take this function or the detail of this function or reference this function or entire code of this function to the CPU in parallel with main thread. So I had one thread already, it's called main thread. One more now I thread we have is A thread. And now we have one more thread, it's called B thread. Means this function thread. So technically if I run this program, 3 thread will run. 3 thread will run. Okay, that's what I want to show you. Okay, and because our requirement is to run A and B function as a thread, I mean to say in parallel. Okay, we don't have to call in this way. That's all. So technically by looking at this code, I can say this code have one thread, 2 thread, and entire code is also one kind of thread. It's called main thread. So 3 threads we have. Okay, so let me close this file and let me show you after executing this file. And I'm executing this file, and what you will see here, maybe some interesting thing here, you will see here, when I run this, nothing will happen. As soon as I run, I hit close. Okay, why is close? Because I asked this guy to create this variable, they created. I asked this guy to create the function, they created. I asked this guy to create this thread, they created. So I only asked these guys to create everything, they created, and that's all. and after they created, the program complete and this stops. But here what we have to do, we have to ask this guy not only create the thread, also to start the thread. And for this guys, what you do, you have to store this thread into one variable, or I can say we have to store this thread in one, let's say one variable called x1. Or let me store this into one variable called x2. So x1, x2 is just a variable that contain that that I know I am a thread. And because I am the thread, I have to run. So for this guys, we have function called start. So if you want to start the thread, it means you want this thread start. It means you want the data of this function, in this function, execute by the CPU in the parallel with the main function. So in the threading module guys, internally they have a function called start. And not only x1 start, I want x2 also start. So guys, start will create and start this thread. Not create, this will create the thread, but start will start the thread and send you to the CPU. Now the magical thing happen. The magical thing is now I can say this program is a multi-threaded program, and I can count 1, 2, and entire code is 1. Total 3 threads we have. And now we have 3 threads. So entire code run in the main thread. This is second thread run and third thread run. Or because these 2 thread also run, and this 2 thread guys call A and B function, and A function will print this and B function will print this, obviously in parallel. That's what we wanted, right? So when I run this, now you can see guys, if you notice here, A and B is printing in the parallel. A print, B print, A print, B print. So I keep on going to my CPU, or my thread is keep on going to CPU and say CPU run this, CPU run this, CPU run this, CPU run this. Or I can say both the things go to CPU. And because CPU is so fast, so in a mini nanosecond they run this guy multiple times. A mini nanosecond they run multiple times because they're so fast in running the things. So before they switch this, sometimes also known as context or switching context, we'll discuss maybe in some advanced classes, or the switch. So till time that time they switch, they run these guys lots of time and these guys a lot of time. But technically, if you see here, they are printing both the function together. Even though both the function are infinite loop, but they are printing here. And now if I open one more terminal and try to find the name of the process or PID of this code. So this code is this one, and the process, this is the process of this program, and this is the PID. Now if I go inside the PID folder, this one, and now if I show you the status file, what you will see, according to our calculation, they will have 3 thread. Okay, and if I just go up and you see there's a 3 threads. Or because this process is running 3 thread, so I can say now this process is multi threading. But right now, because these are the infinite loop, you have to use Control C to terminate. There's a different point, but this program is a multi-threading program. Okay, so so guys, final guys, my conclusion here. Even though in the threading we can do lots of other functions also, we have some more functions and we have some more concepts. Okay. So don't worry guys, I just today my focus is to give you the explanation about and some of the internal concepts of the threading or the multi-threading. Then I move to multi-processing, then some GIL and some other advanced topic come up, queue come up, or inter-process communication come up. So we'll try to go as much as detail we go. And this very important for the real world programming perspective. And almost all the main program using multi-threading. One of the simplest example thing, a chat program. So if you are chatting with me, okay, so I am sending something you, but you also sending something to me. So it means if you are sending something to me, means I am receiving. So if I am receiving, so I should have receive function. But at the same time, I should also have send function. Or it means send function and receive function should run in parallel. Otherwise, you know what happen guys, till the time I'm sending, I can't able to receive. Or if I'm receiving, I won't able to send. Or maybe my program can maybe hang up. But normally if you see in the chat program, we can send and receive in parallel. because we have one function for sending, we have one function for receiving, and both the function are running in parallel with the help of thread, or I can say multi-thread. So if you guys try to think in any of the example, if you see in one process, one program, multiple things happen in the parallel, even though they haven't completed yet or completely done yet by the CPU. Most probably they are using multi-threading. Okay, this topic is not yet complete in lots of areas. When I go for some more advanced topic of networking programs, we gonna use this concept a lot, and that time I will give you some more extra functions and the concepts of the thread. Okay, so I think guys you got the idea. Okay, what is multi-threading, but multiple times this concept will repeat. You become more and more comfortable with this topic. So normally multi-threading come in the advanced topic of Python or maybe some other programming language. I think you guys got the idea how the thing works. Okay, so that's all guys for today. We'll see you guys in the next weekend. We will go more deep dive in this concept, or maybe next weekend we might continue some other topic. So I'm taking guys multiple topics in some different sequence, so you'll get a complete flavor of the language, and slowly we also going and diving in all those concepts also. So that's all guys for today. I'm enabling the the chat window here. Any questions or any query you have about this topic, you guys can ask me. Okay, so 1 minute. So guys, chat window has been enabled. Any queries, any questions about multi-threading, you can ask me. But if you want to know more about use cases, so 2 or 3 different use cases I explain you. Programming perspective, I explain the context or the syntax. Okay, I'll also share this code in your Google Doc. Okay, but any conceptual wise difference you can ask me guys. Yes, Pallavi, you can use Python code to some kind of attendance system we can create, even though you can create one kind of web application website that we'll discuss more in detail, and create some attendance system for the teacher. Okay, so anything you can do guys. It's not a complex thing, right? So how we can start multi-threading in Windows? Exactly same. There is no difference in the code. I by chance use Linux. To try to explain you in depth. To go inside the proc file, even though the way I explain the go/proc folder, it is not at all the part of the Python classes, but because we have a little bit Linux knowledge, right? So try to utilize this knowledge, so that I go inside my Linux to show you that demonstration. But yeah, multi-threading is a concept for all the ways, and syntax, because Python is cross-platform, you can use same syntax in Windows also. So why we have 3 thread? Because we have only 2. Neha explain you, because because I used 2 statement or 2 thread function. Okay, so 2 thread come from the thread function, and 1 main thread. Main thread means come from main program. So main thread is always there. If you do something, if you don't do something, okay. So so that's all guys. So that's the reason we have total 3 thread. Guys, today I show you how to just go inside and see the PID as a folder. But till that guys, from my side, I haven't explained you and give the answer how to read the RAM as a data. And this is one of the tasks Akash I have given to you and everyone over here. So I think you guys are searching, but maybe in some of my classes I definitely give this answer. Or what if you use Control X, guys? OS to OS, the shortcut vary to terminate the process. Normally in Linux we use Control C to terminate the process, but in in Windows, we normally use Control X in most of the times to terminate the process. So so guys, it is OS to OS, but technically your choice which shortcut you want to use, which OS you're using. Yes, I'll definitely try in my upcoming class to take some extra classes of cryptography. So we'll definitely will try. Yes, Permanent, a very interesting question you ask. If you guys want to pass some parameter in the function, so in the thread function we have one more option that's called argument options. So the option I use is called target. Same way you can add comma and you can use argument args equals to, and there you can pass the argument if function needs some parameters. Okay, so that's where you can use. But if you want, I'll show you some of the example in my future classes that we have to use a lot. So I'll show you there also. So what is hyperthreading, Mayank? It is not at all linked to the programming perspective, but if you want, we might discuss somewhere. It is not at all as such linked much about with respect to programming concepts. Much about, right? Okay. So why program will make CPU understand the keyboard key define what? So actually, Rajan, keyboard key is not understood by CPU. So whenever you use any keyboard key and shortcut, we pass those shortcut to our program. So there's some program running behind this. For example, right now if I use Control C, okay, in this program, what I have in my system, this is a Firefox, for example, Chrome I have. So here the Control C means copy. But if I use Control C on the top of terminal, for them is terminate. So every process the one, or program is the one who get the signal or the key. That's called key maps. And they will get, and they program will send to the CPU. Then CPU understood. But my shortcut never directly go to the CPU. That's what I'm trying to explain here is. Can we store one process multi-thread? Guys, by chance, it is not known as a process. It is called thread. So your question, guys, might be, can we stop one one thread in the process? Answer: yes. There's some functions available. If you go to threading module, you can use dir command. You can find some functions available. You can stop while running. Okay. So there might be a lot of questions, guys. A lot of practicals. Maybe we can pause, we can resume, we can join, we can stop. So today my plan is to give you the core concepts and some demo. But we will use this concept a lot in the future classes. So there you see more and more functions, guys. So. So guys, I think most of the questions I'll try to touch over here, but maybe this concept will come multiple times. Other query you ask me, it will be solved and resolved. So I just want to conclude, guys, for today's class.